Welcome to the first video for Computer Science A where we actually get to do something that seems like it's actually related to computer science. So now that you have actually everything installed on the computer, we're going to go ahead and actually write our first program, take a look at some different variables, and of course see how to run the things that we write. So the IDE that we're using is Atom, which we should already have installed. Of course, there's nothing in there. Yours may look something similar to this or maybe a little bit different. But once you clear everything out, we're kind of down to just nothing. So what I want to do is create my first folder that I am going to be able to put stuff in, and then actually run the things that I created in there. So I'm actually going to start elsewhere besides Atom. I'm going to find some place I'm going to create this folder at. And actually the first place I'm going to do it is where I would not suggest that you do it at. I would find a nice place in your user folder someplace, but just for these videos that I'm going to be making, I'm going to go ahead and make a new folder just on my desktop, so that it's everything's there that we can see. So I'm going to call this, call it Computer Science A. Would make sense, and then I'm going to try and organize everything in here as we go. So not only am I going to make this Computer Science A, but I'm going to throw another folder in here, which is going to be called Unit 1. Folder Unit 1. So that we can go ahead and start putting things in here and kind of maybe remain organized. So wherever you want to put that folder is up to you. Just go ahead and find some place that you're going to remember, obviously, and that you can keep track of. So here it is. The reason I made it there first is so now I can go back to Atom, and I actually opened up a second one. I just want to reopen what I had. And add that project folder. So I've created the folder on the computer already. I now need to tell Atom where it is so that it can access it. So the way that I'm going to do this, and I'm not going to use these buttons because later on I'm going to add more things as well. I need to know where they're at. But in here, I have the option to add a project folder. This is under File. I don't want to open a file or open a folder or anything like that. I actually want to add a project folder, so that's always going to be there for me. I don't have to search for each time. So if I add a project folder, it's going to ask me where it's looking. And no, I do not want the tic-tac-toe machine I was working on. But I'm going to go back to my desktop, and let's see, what did I just name this? This was called Computer Science A. And so I'm going to go ahead and select that folder, and with it comes all the things obviously inside of it. And so now I have access to this every time. So if I were to close out of Atom and bring it back open, that project folder will remain. This is not the folder itself, of course. The folder exists on the computer. This is just kind of like a shortcut to it, and so I can see it visually. Now, it's worth noting that whenever I create things in Atom and place things in here or delete things in here, that does change the actual files and folders that are on my computer, so I have to be careful of that as well. So now we've done that, my goal is, of course, to actually write my first Java program. So I'm going to go ahead and right-click on this folder that I'm going to be placing my file into. And I'm going to ask for it to make a new file for me. And as is typical and somewhat required, the very first program that we're going to write is, of course, hello world dot Java. All right, so hello world is the name of the file, and then dot Java is telling us what type of file it is, the file extension. And in this case, since I'm writing a Java program, not a Python program or a JavaScript program or HTML, whatever, this is a Java file. I will end it in .java. So I have hello world.java, hit enter, and so now I have this blank canvas to work on and write this hello world.java file. So there's some things that go into it first. Not everything's going to make sense right away. There's kind of, whenever we get into a new programming language, sometimes it's required to just accept that some things are required and necessary at first, and then we'll figure out why they are later. So here's what it's going to look like to start off with. Every program is going to start off in a similar way, where I'm going to start off this public class. All right, so For those of you that are coming from JavaScript, JavaScript is a scripting language. It's meant to just kind of run within other things. And so it's not this, language that just typically gets run by itself. And so it's kind of a functional language where we're writing functions that can be used elsewhere. It's a scripting language, really what it is. Java, on the other hand, though, is what's called an object-oriented language or a class-based language. And so what that means is that everything that we do is within these things called classes. And those are the programs that are actually self-contained and can run by themselves. So in this case, what we're starting off here is saying that we are going to create a public, so something that can be used by outside of this file. Class is, this is a class that I'm making that's going to contain some things in it. And then I actually need to call it whatever the name of my file was. So in this case, it was hello world, right? So whatever your file name was has to be the name of the class that you're making. If you call it something different, then that should be your name here. So then I'm going to go with these curly braces here. Everything that goes inside these curly braces are now a part of this class. And that is what's actually, in a second here, we're going to write what's going to actually be run. But this is the hello world class that we're working with. And that'll make a lot more sense when we get later into the year and actually talk about methods or creating objects or things that actually go inside these classes. So the next thing that we need, which almost all Java files are going to have, is public static void and then main string array args. Okay, so what just happened here? That was a lot. What we're defining is what's called a method. We're going to spend a whole unit later on methods, so it's not super important to understand what it is now, other than it's a function, right? And what this function is saying is that it's publicly available. Static, I'm not going to get into right now. Void is that it's not going to return anything. We're going to print something here, which is not the same as returning. It's not actually returning a value. The main method is this name that we must give to this method. This is when we go to run my Java file here in a bit. The main method is what it's actually looking for. I could write some other methods in here that are not called main. They will not get run unless they are called somewhere else in the program. The main method, though, is what's actually being looked for whenever we try and run the program later. This is where typically goes, not typically, this is where the inputs go, the arguments that get put into the function. What it's saying is that it takes in a string array, which doesn't mean anything to us yet, called args. We're not actually going to use it, but that is the input that it takes in. Okay, so then our goal is to have this actually do something. And what is typical, what is the tradition, is that we need to, of course, print out hello world. So for those of you guys that are coming from JavaScript, you know that in JavaScript, if I want to print something out, it's console.log. Log. However, console.log is not the method that we're going to call here. It is something slightly different. It is system.out.print. All right, so there's two different versions of this that we're going to separate here in a second. There's print and there's print line. I'm going to use print line for right now, and I'll explain that here in a bit. But print line, and then I need to put inside a string that is going to be print out. In this case, of course, that string is going to be hello world, exclamation point. All right, and then I end with a semicolon to finish out my line. So this is my first program. Not super exciting. Again, there's a lot here that we don't understand what's going on, and that's fine, but I'm going to go ahead, hit Control S to save it. And now the question is, this is the interesting part, how am I going to run this? So the way that I run Java programs on the computer is once I've installed Java on my machine, I will be able to use the Java functions in the command line to be able to run programs. So what I'm going to do is I'm going to open up my command line, which is on the other screen. Here it is. And we're going to figure out how to navigate to the location that I'm currently at. So in the command line, what you'll notice is this description of my current location. What I mean by that is we're used to a lot of times looking at files visually in File Explorer, trying to figure out where they're at. However, what we're going to do in the command line is everything text-based. So this is the hierarchy that we're working through. There's a couple commands that I'm going to use here. The first command that I'm going to look at is called directory, so dir. What this is going to do is it's going to show me all the files or folders that are within my C drive, the users folder, and then this is my username folder within there. And so dir is going to tell me, it's asking the computer to tell me what is in this current directory. So if I hit dir, what it's going to tell me is, what did I do? Enter, please. Oh, there we go. It's going to tell me a bunch of different things that are in my current directory. You can see in here I've got all my common things. These are just whatever stuff is typically on or under your username. And so it listed them all out for me. And what you'll see is that all these folders within here are things in that I can navigate to. So I have to stop and ask myself, okay, well, so where is the file that I just made? And the answer is it's on my desktop. All right, again, not a great place to put it, but that's where we did, and you hopefully put it someplace else. So how do I get there? Well, so I can see the desktop is one of the folders that is within my user folder. So perfect, I just didn't get there. So what we're going to use is a command called change directory. It's cd. Now before I actually navigate to desktop, I'm going to show you one thing because we need to also sometimes know how to back up. If I want to go up a folder, so I'm currently in my username folder, I can hit cd and then dot dot. So cd dot 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 will take me up a folder. Enter. And so now I am in my users folder. I moved up one level, and I can take a look at what's inside there. Nothing, because I am the only user on this computer. So I can navigate back though to the folder I just came from by typing in change directory. Instead of hitting dot dot this time, I'm going to change directories to my username folder. So cd, and there it is. And then like we just looked at before, I'm trying to make it to my desktop, of which I can see a desktop is one of the folders in there. So I'm going to cd and then desktop. Helpful hint is that if I don't want to type in this whole thing, I can hit tab to auto-complete it. And if I keep hitting tab, it'll rotate through all the possible. So if actually I back up, I just have D. If I hit tab, it'll rotate through all the different files that start with the letter D. So if I type in enough, then I'm good. So change directory to desktop. And then I want to change my directory to, what do we call this? Computer science something. Oh, it's not it. There it is. Computer science A. So I'm going to change my directory again, and then one more time to get to, what did I call it? Unit 1. Perfect. Okay. And now here I am. I can hit dir again to see what's in there. The only thing that's in there is hello world.java, which makes sense because we just put it there. So I've successfully navigated my way to the folder that I want to be in. I found hello world.java, and now my goal is to actually run that program. So what I have to do, assuming that, and now I'm a little bit nervous I don't have this set up correctly because I didn't think to check it ahead of time, but we'll find out here in a second. If I have Java installed correctly, and it knows where the path is and knows where to find it, I should be able to run this program. So here's what I'm going to do. So the first thing I need to do is I need to do what's called compiling my program. So we wrote hello world.java in what's called plain text. It's something that we can understand, but the computer can't. And so what we need to do is a process called compiling that turns it into a file that the computer can read. It would make more sense. Why can't the computer just do it on its own when we ask it to run? And the answer is a couple things. Number one, when I run the compiler, it's going to check to make sure that I don't have any errors in it. And number two, later on, like if we wanted to combine, like if we have multiple files that are all working towards one project, the compiler is what can actually like compile them all into one thing for us. That's where the word compiler comes from. Anyway, so the command for that is Java C, Java compile. So if I hit Java C in the name of the file that I want to compile, hello world.java, I hit enter. It's a moment of truth. Thank goodness. All right. If nothing happens, that is perfect. All right. If something happens here, several different situations. You might not have Java installed correctly. It'll tell you that it doesn't recognize the Java C command. Or if you have an error, which we're going to talk about here in a bit, if you have an error or an exception, it'll let you know. But luckily we programmed this correctly, and so we're good. So I compiled it, and if we actually take a look, so if you go back and look, because it's up right here right now, if you look, there's another file inside of my Unit 1 folder now. It's called helloworld.class. So this class file is, and actually let's go take a look at this for a second. This class file is what's readable by the computer. If I open this, it is a bunch of garbage. I can't read any of this because all these things, the computer right now is trying to convert these like boxes, trying to convert them to ASCII characters, but doesn't know what to do with them. And that's because they're not meant to be converted to ASCII characters. This is all stuff that the computer is going to be reading to actually, run whatever this program is that we just wrote. So, not readable by us, readable by computer though. So if I actually want to run this, then I'm going to hit Java, and then I'm going to give it the name of the program that we just wrote, Hello World. All right. If I do that, Hello World is the name. So you'll notice the first time when I compiled it, I was telling it the file. Now I'm just telling it the name of the class that I'm trying to run. I'll say Java Hello World, and I will get, of course, Hello World. So we did it. That was our first program. It was great. It was awesome. Done. Awesome. Okay, so let's go back then to our program and talk about maybe some more things that are going on here. So one of the things that I told you was that there's actually another function, system.out.print, that does something very similar to print line, but slightly different. Let's look at a couple examples here. So let's system.out.print, just print, and we're going to call this print line 1. Okay, so this should print out line 1 for me. I'm going to go ahead and Control C and throw this down here again. This is going to be line 2. I'm going to change this to line 3, and then one more, system.out.print. I don't know why I didn't copy there. And then line 4. Okay. So, let us go ahead and just run this and see if we can figure out what the difference is between the original program, or between print and print line. So, okay, actually let me backspace real quick. Pro tip here is that what I just did without even thinking about it, if I hit the up arrow, it will bring back, I guess I just got rid of it. If I hit the up arrow, it'll bring back the previously run command in the command prompt. So if I want to go up 2 spaces to what I ran 2 before, I hit the up arrow twice. And so instead of typing out Java compile hello world.java again, I just hit up arrow twice, and here it is. And I hit enter, compiled, perfect. Now if I hit up arrow twice, oh, how did I do that? Okay, there we go. Hit down to get it. I get Java and then hello world. All right. Line 1, line 2, line 3 are all on the first line, then line 4 is on the second. Why, oh, why? Okay, so let's think about what's going on here. So, what print does versus what, what print does versus what print line does is prints out the statement that I just had and does nothing else. So, what this first line of code does, it prints line 1. Here it is, line 1. Then we get to the second line of code. It says print line 2. Well, print doesn't do anything except for print line 2. Then here's what print line does. Here's the big difference between print and print line. Print line prints out what's in the method, in this case line 3, and then prints a new line to go after it. So I print line 3 and then new line. And so then when I get to the fourth line of code here, print line 4, it'll print out line 4, and that's why you'll notice I have this gap underneath. It prints out a new line again. If I didn't have print line here, if I just use print, then this next command line would, this next command line would be right next to it. right below it. But there's this gap in between. So that's the difference between print and print line. Subtle difference, but worth knowing because we'll use both of those a lot. One of the things I've kind of glossed over, but it's worth referring to, is the fact that this is called a string literal. We're going to talk more about primitive types in just a second, but I guess I should be clear, strings are not primitive types. They usually get thrown in with the primitive types just because they usually are all taught at the same time, but strings are not primitives. This is called a string literal, though, because this literally has the value, holds this value of what's inside it. You might be asking yourself, well, how would I write it differently? Why can't I just call it a string? And that'll become clear later when we start referring to strings using variable names, versus we can also refer to strings by their quotation marks. And so these are called string literals. That would make sense. I know I've said this, I don't know, about 20 times so far, but that'll make sense later. Don't worry about it right now. But that is a name that we need to know, string literal. Okay, let's see. Where are we at? Things I want to talk about. So I think I told you that whenever I run this, we lucked out the first time and didn't make any errors in our code. I compiled it, nothing happened, and then I ran it. All was good. However, obviously, sometimes I can write things and they could go poorly, and so what I can get three different things. I can get what's called a syntax error, I can get what's called an exception, or I can get what's called a logic error. And so let's see what some of those look like. So a syntax error would be like, whenever I write system.out.print, there is a particular spelling of the word print that I have to use. If I were to change the word print to something else, the computer obviously no longer knows what I'm talking about because that doesn't say print, that says pint. So if I were to save this and go and run this, so Java compile and hello world, I will hit enter and it will tell me, see, Java's so nice, unlike JavaScript sometimes, it just seems like so unhelpful. Java is trying to be as helpful as possible. So what it's telling us is that in your program, hello world.java, on line 3, there's an error. There is a symbol that it does not know what we're talking about. It's good with system, it's good with out, and then it says we try to call this thing called pint. It doesn't know what that is. In fact, it tells us we're trying to call this method called pint. It doesn't know what it is. So this is what we refer to as a syntax error. This is something we can easily go back and fix, but the program will not run, or rather will not compile without us fixing that. So I have to go back and I have to fix print, and that fixes my syntax error. Exceptions are a little bit different. We'll, again, spend a whole lot of time talking about exceptions later. Exceptions are things like when you do something, you didn't really do anything wrong, but something went wrong in the program that shouldn't have. So, for example, if you know what an array is, like if we try to go out of bounds on an array, that'll throw an exception. If we try to divide by 0, that'll throw an exception. If we try to read a file that isn't actually there, that'll throw an exception. So we didn't type anything in wrong, we didn't name anything incorrectly necessarily, but something's wrong with the program and an exception will be thrown. So that's number 2, and then thing number 3 is a logic error. A logic error is really like you screwed up. The computer's still going to run it. It's still going to compile, but like you messed something up and you did something incorrectly. That's like, I tried to add 2 numbers together and I subtracted. Or this isn't really a strong logic error, but like I meant for this to say line 4 and I wrote line 5 instead. Like that was just a mistake that I made. The computer's still going to run it. It's not going to know any different. It's going to be happy and do whatever. But I made a mistake. So that is what a logic error is. So those are 3 big things: syntax errors, exceptions, and logic errors that we'll run into along the way. All right. One important thing that I also glossed over that I should reference is, of course, whenever we are writing our programs, we should add documentation that lets people know what's going on. So the question is, how do I comment? And the answer is with these double slashes. All right. So if I want to comment and say, this will print out line 1 1, this is a comment. All right, these two slashes are a comment. This is an inline comment. We can have other comments, which we'll talk about later, that I never really use, but these are inline comments. So if I want to remind myself, hey, this will print out line 1, this will print on the same line, and so will that, but this is a different line. I can add comments in here, which are of course super useful and helpful for people later to come in and read our programs. Okay, those are comments. Great. And now the last thing that we need to talk about is, of course, creating variables that we want to be able to reference. So there are, according to Computer Science A, 3 different primitive types that you should know. They really are going to harp on 3 different primitive types, and then, but we're going to find out is actually an object later, but strings, okay, which we already kind of talked about. So the 3 primitive types that they're going to make a big deal about are Booleans. They are ints, which is short for integer, and they are doubles. Okay. No, stop, please. Okay. And doubles. All right. Doubles is probably the only one that's like super confusing as to what it is. It is unclear. So I think we need a little bit of background information. Now I'm going to bring up a website that I find super useful. So if I'm going to go to yeah, I'll do this. So if I were to go to the Google and I were to search for Java, let's see, Java and then primitive types, I'm going to try to, don't do this to me now. Okay, I'm not a robot. Here are the traffic lights. Nailed it. Oh, more traffic lights. There they are. There's our one. Okay, perfect. Nailed it. Okay. So there are a couple different resources that are super useful to me. Number 1, the hands down most useful resource is, of course, the documents from Oracle themselves. So like Oracle, the owners of Java, these are their official documents. The reason that I'm not going to use them a lot, and I'm not going to reference them too often, is that they're kind of complicated, like for a person new to computer science to understand. However, we'll use them a whole bunch more later. And so actually this is pretty solid, but I want to show you some of my resources. This one, I have no idea how to pronounce it, is usually pretty good. They got solid stuff. I'll leave that right there. W3 Schools is okay. Wikibooks. There's one in particular that I want to. Here it is. Geeks for Geeks. This is probably my favorite. They got solid stuff. They do a pretty good job explaining things. And so this is probably the number 1 that I would suggest for you if you Google a Java topic, to start here. And so here are the different types of primitives in Java. This is all of them. The AP Computer Science A exam is not going to expect you to know all of these. However, it's worth noting that they exist. So here they are. So Booleans. Booleans are 1-bit primitives that just contain true or false. Simple as that. The next category would be these: byte character, which people refer to as char. I hate that. Character. Short. Int for integer, and then long. All right. So these all contain whole numbers, kind of. All right. So the one that we'll use most commonly is int, or integer. We're going to talk a whole bunch later about these sizes here and why they're important. It's 32 bits in size. So if capacity is an issue, you can store something, whole numbers, in a slightly smaller size, which is called a short, or an even smaller size, which is called a byte. And then this other one, characters, specifically, I mean, they still store whole numbers, but they're meant to represent ASCII values. And so we'll use those whenever referring to letters or different ASCII characters of some kind. And so these are all integer type values or whole numbers. And you'll see over here the range of which they can hold as well, but again, we'll get more into that later. The last type is what's called a floating point number. So if I want to include things that are have decimal points in them, or better known as radix. Actually, they're not better known. More properly known as radix points. They're floating point numbers, and so the most basic of them is just called a float. It's 32 bits. However, you can only get up to 7 decimal places, which a lot of times is not enough. Because when we're talking about 7 decimal places, I'm not talking about 7 places past the decimal point. I'm talking about 7 places on either side of the decimal point, which is a lot of times not enough. And so what we do a lot of times, and this is why it's kind of the standard now, is to use something that is twice as big in terms of number of bits, which, as you can probably guess, is a lot bigger in terms of the actual size, and that's what's called a double. So doubles are 64 bits then. They can hold up to 16 decimal digits, which is a lot. So these are all the different primitive types in Java, but like I said, Computer Science A only really cares about, Booleans. I can't remember. These come up sometimes, but I don't think they care too much about it. Integers, and then doubles. So those are the things that we care the most about. All right, throw that back over here. Perfect. Okay, so how do I actually write these things? So there's two different ideas here. There's what's called declaring a variable and what's called initializing a variable. So let's say I want to create a Boolean. I create a Boolean variable. It is to test to see whether or not, I don't know, we're going to have a quiz tomorrow. So it's going to be a Boolean called quiz. This, if I just stopped right here, this is called a declaration. I have created the variable. I have not done anything with it. It just exists. It holds no value yet, kind of. That'll be a discussion for later. And so there's a second part here, which is if I want to give it a value, I can say that quiz is equal to, are we going to have a quiz tomorrow? We will not. So false. Okay. So this is what's called initializing then. I've initialized my variable. I've taken the value false and stored it in quiz. Now, typically we won't do these in two separate lines, although we could. We can both declare and initialize something on the same line. So, for example, if I want to store my favorite number, I can do that all in one line. So I've declared it, integer favorite number equals, and then it's the number 42. Okay. So I have both declared and initialized my favorite number on the same line. Also, one thing worth noting is you'll notice here that when I wrote the name here, favorite number, I used what is called Camel Case. If I have a name for a variable that is multiple words long, what I typically do is I do not capitalize the first letter, and I capitalize the first letter in every word after that. Typically, we don't capitalize the first letter because when we do that, it means something else to us. Generally, that's what we do for like classes. So like Hello World was capitalized. You could, to be clear, the computer doesn't know the difference. It's just a convention for us. So that's how I declare and initialize values. I can also, when I go to name this, I can have numbers in here. I can have underscores if I want. I cannot, though, start with a number. And I cannot include special symbols like this. I cannot do those things. So this is fine. It looks kind of gross. I don't like this. I just hate it. So I'm gonna delete those. But those are the things that we can do whenever we're naming. The other thing that we have to keep in mind is we can't use what are called reserved words. What reserved words are things that are reserved in Java. They actually mean something. For example, we cannot name a variable Boolean. It means something in Java. We cannot name a variable static or class or public, right? Those actually mean something in Java. So there's a whole bunch of words that they'll come up along the way that we can actually use. The last thing that's worth noting, and this is kind of a side note because it's not super important, but it'll come up here and there, is if I want to declare a variable, because as of right now, I can change the value of favorite number to something else. I would never want to change it, of course, but I could later on. I could say that my favorite number is actually, oh, this pains me, 4. And that's fine. You know, I can change the value, no big deal. it's whatever. However, if I want to make something that cannot change, what I can do is put an extra keyword out here in front, and that keyword is final. If I put final out in front, I can write final, integer, favorite number, and this is telling us that it's the word I'm going to use is called immutable. We'll talk about a whole bunch about immutable things later in the course as well, but that means it can't be changed. And so typically what our convention is that if we we also refer this to as a constant a lot of times because it can't be changed. It is our convention that we capitalize this. So then if I want to dot out dot print line favorite, yes please, number. I can do all that. This is all dandy. I haven't run anything in a while. I should do that. Yep. No errors. Perfect. And where is it? Fine. I give up. There it is. Perfect. 42. How about that? Now, let's see what happens if I try and change this. What if I say that favor, thank you, equals 4. Say this again. So now I should print out 4. And what's going to happen? Oh, it's not going to let me. It says, so this is an error. This is cannot assign a value to final variable favorite number. It says, yeah, so it's already a final variable, so I cannot change the value. So that's too bad. I guess I'm stuck with 42. So I'll just get rid of this, and I will go on my merry way. All right, so let us sum up here, because we did a lot of things. Did I do all the things I wanted to? I think I did all the things I wanted to. Man, we talked about file systems. We talked about how to, well, we set up Atom in the first place. We talked about how to run things on the command line. Talked about syntax errors, exceptions, logical errors. We defined what string literal was. We added comments. We talked about declaring versus initializing. Talked about our primitives, booleans, ints, doubles. Strings are not a primitive, they're an object, but we typically talk about them in the same way. Talked about Geeks for Geeks, what a great website. And then we talked about how to name variables. All right, that's productive. Oh, and finals, of course. All right, so that's kind of our introduction to writing these programs in Java. You know, a lot of this is not totally new information because we already kind of know about programming, but hey, we're finally actually getting to know how to do things on the computer itself, and then some syntax-specific things for Java. So next we're going to move into some things that are slightly more interesting, using these variables, maybe some arithmetic operations. It'll be a good time, but that'll be the next video, so I'll see you then.